graders. I apologize for having to do the videos this way, but you do what you gotta do. All right, we are again in our blue book, and we're going to be going over page 312, 313. This is going to finish up your lessons on perimeter and area. So tomorrow, what we will do on Wednesday is we will be reviewing our green pages, which is going to go back over this entire lesson. And then on Thursday, we're going to do a big review where we're going to go over everything that we have learned through this entire unit on perimeter and area for your assessment you will take on Friday. So we're on page 312 in our blue book. They have drawn us a shape that has 2 rows and 4 columns. So it looks like this is what you should be seeing in your book. 2 rows. I'm going to go ahead and label all my sides. 4, not 5. Label all my sides so I'll have those ready for my perimeter and for my area. It says you can use drawings to help you find rectangles with the same perimeter and different areas. The perimeter of this rectangle was 12. Let's see how they found 12. Remember, perimeter, we go all the way around. So P equals 4 plus 2 plus 4 plus 2, that would be 6 plus 6, which is 12. So we can see that we have a perimeter around this shape is 12. So we want to come up with other ways to have a perimeter of 12. And you can see they did one that has 1, 2, well, let's see this first one. Let's look. Has 4 rows, so it looks like this. 4 rows, I didn't do those equally, did I? And 1 column, so that would be 4 plus 1 plus 4 plus 1. Is that 12? 4, 5, 6, 7, 8, 9, 10. That's only 10. Did I miscount? 1, 2, 3, 4, 5. Oh, good, because that looks better anyway with adding that extra line. So it's 5, 5, 1, and 1, right? So 5, 6 plus 5 plus 1 is 12. Then they did one that was 4 rows, so it looks like this. And 2 columns, which is basically this one turned up. So 4, 2, 4, 2. We know that's 12 because that's the same numbers. Then they did one that has what? 3 rows, I believe, and 3 columns. 3 plus 3 is 6 plus 3, 9 plus 3 is 12. And then they took this one here and they just laid it down on the ground. So it was just 1 row and then the 5. Yeah. And so all of these should still have a perimeter of 12. 1 plus 5 plus 1 plus 5 should be 12. 3 plus 3 plus 3 plus 3 should be 12. 4 plus 2 plus 4 plus 2 should be 12. 5 plus 1 plus 5 plus 1 should be 12. And then we already know our original one was also 12. Are their areas the same? Area, remember we're going to count the inside squares. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, only 5, so that's not the same. 1, 2, 3, 4, 5, 6, 7, 8. That one is the same. It's basically the same shape. They just turned it. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not the same. And then 1, 2, 3, 4, 5. That's not the same. So different areas, but their perimeters are all matching. All right, number 14. This is on page 313. We're going to use these pictures to help us. Look at the model at table. What do you notice about the sum of the length and width of each rectangle? Look at your sum. Remember, your sum is where you added, so that would be our perimeter, because we're doing perimeter, and sum means to add. So if we look at our perimeter, what do you notice about everything written in your perimeter? the total perimeter is all 12. So let's go back and look at the length and width. Let's add those up. What's 1 plus 5? 6. What's 2 plus 4? 6. What's 3 plus 3? 6. These are all my lengths and widths in my chart, remember. What's 4 and 2? 6. And what is 5 and 1? 6. So if I do a sum of my lengths and widths on my chart, they're always going to equal 6. So let's say this is number 14. The sum is 6, because that's what's happening. When I add the length and width, I keep getting 6. Notice, look at number 14. How does the sum of the length and width compare to the perimeter? The sum of your length and width is half of your perimeter, isn't it? Because our perimeter was 12. So our sum, the sum of length and width is half the perimeter. That's going to help us later on when we're trying to figure out our own numbers. Whatever our perimeter is, we come up with what is half of that. If I cut it in half, what would that number be? And then I will make sure that my length and width adds together to equal that half. So let's go to number 15. All of the rectangles have the same perimeter as Kaya's rectangle. Only one has the same area as Kaya's rectangle. What else is the same about the rectangle in Kaya's rectangle? So let's find the one that matched the area. We know the perimeters match. What was the area? 1, 2, 3, 4, 5, 6, 7, 8. Which one matched that 8? This one, didn't it? Let me circle that one. This is the only one that matches. What do you notice about that one? What else is the same? The lengths and the widths, aren't they? So let's tell them that on number 13. The side lengths are the same. They really did not draw a different rectangle, in my opinion. They took the same rectangle and they just turned it up. It's still 2 and 4, 2 and 4, all the way around. So to me, that's still the same rectangle. Number 16. Can two rectangles have the same perimeter but a different area? Yeah, absolutely. So 16, yes. Yes. They can have different side lengths but still add up to be the same perimeter. So different lengths can add to get the same perimeter, but a different area. I'm going to read that back to you. Whoops. So one more time, the question is asking, can I draw rectangles that have the same perimeter but a different area? Yes, absolutely. We just proved that. We have all these rectangles over here that have, this is the only one that has a matching area. The other three that have the same perimeter do not have a matching area. They're using different squares inside, different numbers of squares. So we said yes, different lengths can add to get the same perimeter, but a different area. You're not doing the same math when you do perimeter and area, so it makes sense that they're not going to match because you're doing a different multiplication fact when you're doing area. All right, the triads are going to be for you guys to do. So you're going to be given a shape that has rows and columns. They already put the squares in there. You're going to need to find your perimeter of that shape and go ahead and find that area too. And then think about what we said. If I want to draw a rectangle that has the same perimeter, what I need to do is take half of my perimeter. So if I get 18, half of that would be 9. And then I want to make sure that the two sides, my length and width, if I add those together, would also equal 9. So whatever half of your perimeter is, come up with two numbers that you can add together to equal that half. And that will help you figure out how to draw your rectangle. And then number 18, you're going to look at your rectangle and find your area. Is it greater or less than their rectangle? Figure out what the area of yours is and what the area of theirs is to determine if it's greater or less. When you have finished those two problems, go ahead and tear out page 327 and 328 in your red book, and we will go over the directions of that, and then you will work that for me. Still perimeter and area.